This experiment is significant for understanding probability by making abstract concepts more accessible. It develops skills in data collection and analysis, demonstrating how randomness impacts outcomes in real-world contexts, such as weather prediction and decision making. Additionally, it connects theoretical knowledge to practical applications, showcasing how probability aids in solving problems and making informed choices.
Objective of this experiment is firstly to provide a hands-on approach in understanding the concept of probability and statistics through the activity of spinning the wheel. Second, aim to deepen the understanding of randomness while simultaneously fostering essential skill in data collection, analysis, and interpretation. Third and last, to illustrate how probability can inform decision-making process and problem solving in everyday life.
This trend is going viral right now.
What trend?
It's about eating one color food in 24 hours. Let's go, let's try it.
Yes. Yeah. We can use spin the wheel to choose the color.
Here's the methodology. First, add entries on the spinner according to the colors on the wheel spinner website. Second, tap the spinner to spin the wheel and the result will pop up when the spinner stops. Third, record the outcome in the table. Lastly, repeat step 2 and step 3 for 29 times more. Question 1.
The table shows the outcomes of our experiment on spinning the spinner. We have pink for 6 times, white for 8 times, green 7 times, blue 4 times, orange 1 time, and yellow 4 times.
The experimental probability of the spinner landing on each color. To find it, you have to divide number of time an event occurs over total number of outcomes. As you can see from this example, from our outcome, we get pink 6, white 8, green with 7, blue is 4, orange is 1, and yellow is 4. So it will be divided by 30 and then you will get the outcome. For it will be the experimental probability. Next is the theoretical probability. To find it, you have to divide number of favorable outcomes over total number of possible outcomes. For this case, our spin the wheel has an equal chance of being landed on. So there is 6 color in total. Therefore, we can use the formula number of favorable outcomes over total number of possible outcomes, and just substitute it into the formula, and you will get 6 over 30. And if you simplify it, it will be 1 over 6. So the theoretical probability for our experiment 4 is 1 over 6.
To find the difference between the experimental probability and the theoretical probability, we use the formula where the experimental probability minus with the theoretical probability and multiply with 100% to get the answer in percentage. So, to answer this question, the difference between the experimental probability of the spinner landing on the pink section and the theoretical probability of the spinner landing on the pink section, we minus 1 over 5 with 1 over 6. Then, we get 1 over 30 and multiply with 100%. So, the answer is 3%. Next, the difference between the experimental probability of the spinner landing on the green section and the theoretical probability of the spinner landing on the green section, we minus 7 over 30 with 1 over 6. Then we get 1 over 15 and multiply it with 100%. So the answer is 7%.
To calculate the difference between experimental probability of the spinner landing on wet section and theoretical probability of the spinner landing on wet section is experimental probability is 4 over 15 minus theoretical probability is 1 over 6. Then we get 1 over 10 multiplied by 100%. Then we get 10%. So that's the answer.
For the last section, we have the experimental probability of spinner landing on the pink section. So we are going to take 1 minus with the probability of pink, which is 1 minus 1 over 5, which is equals to 4 over 5.
Question 2.
This is the main question that we need to solve. First, we need to find the value of A. To find the value of A, both function must equal to 1 because of probability function must equal to 1. Then integrate the functions, enter the integral's values and solve the equations. So we get A equal to 5. Second question is to find the expected value of 2z plus 3 in bracket 2. First, we need to find the expected value of random variable z with formula integral z multiplied by function of z. Then we get 3.27. Then we need to expand 2z plus 3 in bracket 2 and we get 4z plus 6 in bracket. So then we need to expand expected value into the bracket. Then we get 4 expected value of random variable z plus expected value of 6. Oh, we already know the expected value of 6 is equal to 6. And we also already know and already find expected value of random variable z, which is 3.27. Then we add all the information into the equation. Then the final answer is 90.08. The last question is to find variance of random variable z with formula expected value in bracket random variable z power of 2 minus expected value of random variable z power of 2. We already know the value of expected value of random variable z, which is 3.27. And we need to find expected value in bracket random variable z power of 2 with formula integral z power of 2 multiplied by function of z. Then we get 11.92. And then we add all information in the equations. Then we get 1.23. So that's the final answer.
To conclude this video, the spinner experiment illustrated probability concept by comparing experimental results from 30 spins with theoretical expectations, showcasing variability, random processes, and the importance of empirical data. It highlighted the value of real-world experimentation, enhancing statistical knowledge and bridging theory with practice while emphasizing probability's relevance in everyday decision making. So that's all from us. Bye.
It's you 날 걱정하니 It's you 나를 깨하니 말은 해도 돼 But what do you say 어디든 언제든지 달려와 바쁜 척도 없이 난 나잖아 이게 말이 되니 난 물어봐 너는 말야 It's not just living in the system baby Oh my god It's on that I was really hoping that it will come through Oh my god 전 너뿐이 I can never